So I highly recommend you apply.
Thank you. Yeah. Okay, so last time we talked about how to do project management, like when you work in a team, whether small or big. Today we're going to talk about how to code effectively when working on a software with a team, and how to resolve some of the conflicts that might arise along the way. Okay, so most of you now are going to do, what you're going to do as an engineer is probably work in a team, whether now or in your future career, and this definitely includes developing software. So what do we want here? We want to basically be able to do parallel development. What does that mean? That means basically multiple team members are working on different parts of the project without wasting work or blocking each other or getting into each other's way while doing that. Okay, we talked earlier in the course basically about how Git resolves some of these issues, but it's not just about on the technical level, it's also more on a non-technical level. We might get into each other's way, and how do we deal with that? Has anyone seen this book or heard of this book? It's called The Mythical Man Month. No, yeah. It's a pretty old book from the 1970s. It's a classic one about software engineering, written by a guy called Fred Brooks. So Fred was basically in charge of a large software project for IBM. IBM at the time was very dominant in the field and one of the top companies. So it was the kind of the project that either you make it or break it, okay? And he was responsible of basically rewriting and releasing a new mainframe operating system for IBM. Now, the project was late, and as it was obvious that it was going to be late, his superiors started asking him, like, okay, how many person months or how many people do you need more on the project? And he gave them a number, basically, I don't know, like maybe 30 more employees. Okay, they added that number, but what he found out that the more people he put on the project, the slower that it got. That was kind of counterintuitive, okay? So why does this happen? It actually kind of happens a lot in software. It's not like you're building a house or like you're shoveling snow where if you add more people, it's probably going to get faster. The problem is in software projects is that there is a communication part. And if you add more people who don't know anything about the project, you will probably waste time of the people who already know because they need to basically explain things to them or communicate with them and get them up to speed. And that makes things go slower. And it will slow down even the people who know what the hell is going on. And there is this famous saying by Fred Brooks. It is actually called Brooks's law, is that adding manpower to a late software project will definitely make it later, makes it later. So basically it will slow things down. Okay, so why am I telling you all of this? The reason is that basically it is hard to speed up a software project that is already late, and we need to look carefully for these techniques that we put here at the top, basically how to do parallel development without blocking each other's way, in order to be able to make forward progress in a team. So how can we do that? I'm going to give you a couple minutes to basically think about this with your teammates. Think about how we're going to do this in this project, for example, like on the scale of this project, starting with milestone 1. What things we need to do in advance or upfront to be able to make sure that the project is going smooth and like you are able to work effectively in the team. Okay, let's do this. Okay, so I heard some good suggestions out there. Anyone wants to buzz in and basically weigh in on this and tell me about one of the suggestions? Yes, B10. Go ahead. Oh, no mic? Yeah.
So one of the things we did is, in our first meeting where we're actually coding, we came to an agreement on certain things like syntax and like naming conventions, because the important part is when we review each other's code, it's important that we don't lose valuable time on things like trying to figure out things like with very convoluted variable names, for example. And so it's important that we come to like some sort of like consensus on how to name things or what our conventions are, and most importantly, like documentation.
Okay.
To include in the comment, like if you're calling other libraries or other functions, for example, or why you're picking a particular data structure.
Yeah, that makes sense. So basically agreeing on a code style kind of upfront, so that when the team members are reading each other's code, they don't waste time basically trying to understand what is going on here. So if you and your teammates agree on like, okay, we're going to use this naming convention for these variable names, or like we're going to use like global variables going to be put somewhere in the code. So this makes things easier as the project gets bigger and bigger. The other thing that he pointed out to is basically to have comments, make sure that your code is well commented, because in this project you are working in a team of 3, but like when you work in the industry, you're gonna probably work with people who you haven't even met before, and the only thing that you know about them is like they wrote this code. But if the code is well commented, basically you will be able to read it. It's really hard to actually just read code, and if it's not well commented, you'll probably get lost in what is this code doing. So this is one of the good things that basically help make things to go smoother in the project. I saw D06 buzzing in. Is that by mistake, or did you buzz in? Did you buzz? Like, did you want to say anything? Okay, never mind. Okay, what else? Any other suggestions? We talked about code style, we talked about comments. Anything simpler, like how to make things effective in a team? So one of the most basic things is basically to communicate. Like make sure that you are meeting regularly, basically to understand each other, understand what each team member is doing, and have this agreement on the task allocation up front. Now, we are working in an agile environment, so sometimes planning is hard from the beginning. But if we have a little bit of planning, a little bit of idea of like what each team member is doing, we can revisit this and maybe in a week or two once like we're approaching the deadline and see how things are going, and then we can basically reiterate and try to redistribute the tasks, or depending on how things are going. Okay, so these are good suggestions. I'm gonna here go through some of the ideas I have. So basically, as I said, the work distribution conversation is something that you have to happen maybe like yesterday if you haven't already done that on milestone 1. So basically you need to discuss all of the functions that are in the M1 header file, and try to basically group these functions together. Discuss who is doing what. It probably doesn't make sense to put like 2 or 3 people on the same function, because they will probably get into each other's way. It's more logical to basically to have one implementer or one person to implement one function. So go over all of these functions. Look at how you can group them together, like group the related functions together. For example, functions that are related to street segments will go into like one implementation, under one implementer. Functions that talk about like OSM IDs, for example, that is probably a different implementation and can go to another person. So split all of these across the 3 members, and if one of the functions that you implemented already works, commit it. Don't wait until you finish all of your code to commit everything, because that will make it difficult once we integrate everything together, and you will probably get into a lot of code conflicts that you will need to resolve manually. And this is a tedious process, and it probably will add some stress closer to the deadline. So always commit when a function works. Don't wait out until all of your code works. Consider the difficulty of the functions when splitting the work. So some functions probably are more difficult than others, and they will probably need more time. So it's not necessarily to like give, for example, I'm gonna give like 4 functions to each member. Sometimes a member will probably spend most of his time on a function or 2 just because that function is more difficult. So it doesn't have to be an equal number of functions, it has to be an equal amount of work, if you think about it properly. Okay, so, and as I said, we are in an agile environment, and sometimes planning can be really difficult upfront, and we probably cannot estimate how difficult a function is upfront, but that's fine. So you can probably start with splitting up, let's say, 2/3 of the functions, okay, and leave out the last third until the end. Not necessarily until the end, I mean until someone finishes, and then they can take up that extra function or 2. So we are always working in a fast environment. We're basically trying to just get things done, see how things work, and then reiterate and revisit the initial plan. And adapt to basically, are we meeting the deadline? If not, maybe we can come up with solutions like I can take over Bob's work, or Bob can take over someone else's work, just to make things done, to get things done, sorry. Oops. Okay, so we talked about, I talked about, one of the things that I talked about was basically splitting up functionality. So how do we make sure that basically we are not getting into each other's way? Now, if everyone is working on a separate file, maybe that's good, because now when you merge those files, Git is smart enough to know that these are independent and they can be merged and without any issues. So let's revisit our old friends, Tony Stark and Bruce Wayne here. They are both working on a separate file, f1 and f2.cpp. They do a git pull. They both build, do their own development. They build, test, make sure everything is working, and then they commit and push. Once they commit and push, basically both of these changes are now in the remote repository, and then similar to what you're probably doing in milestone 1, you will keep basically doing this process over and over again. Git pull, make some changes, and git push. Okay? And I can't emphasize enough that you need to keep doing this over and over. Don't wait out until you integrate all your code. Things are gonna get messy closer to the deadline, and you probably don't want that stress, extra stress added. Okay, but what if that you're both working on something that is common to the whole project? And that's probably gonna happen. Sometimes we'll build extra helper function up front so that we basically be able to use them across different features. And you will definitely hit this issue. So while Git is still smart enough to handle some of the changes, sometimes it will tell you that, okay, there are some extra code conflicts that you need to resolve them manually. But that's fine. And if you plan it ahead, and if you plan upfront that, okay, this common functionality, we'll probably all need it, maybe we need to basically implement it first and finish it first before we actually get into implementing the functions that we are required to implement. Okay. So again, basically, if they both work on f1 and f2.cpp, and they both have the same common functionality, they test, execute, and then they do push. Now, all of the changes are in the remote repository. All of the changes for the helper function is there, so everyone can use it without the extra headache of trying to resolve those conflicts. So this is all to tell you just basically keep integrating and keep pushing your code often without, whenever you finish a certain function. Okay? There is actually a term for this called continuous integration. By continuous, it's basically a practice that we all software developers follow, where we always push our code whenever something works without breaking the build. So we don't want to push code that breaks the build because that will add the extra waste more time for your team members, because now they will have to pull the code and try to, when they try to build it fails, they don't know what's going on, and then there will be extra communication between the team members. Okay, what happened here? So that's why we only push code that is working, or push code that doesn't break the build. Sometimes you probably want, like, build a feature, but you can't find the bug, and you want your friend to look at it. That's fine. You can comment it out, for example, so that you don't break the build, or you don't break tests that were already working, and then they can pull the code and comment it out, or uncomment it and continue working on it. Okay, so this is just to reiterate on what we just talked about, is that always do continuous integration. Always push the code that whenever something is working. It basically minimizes conflicts with other changes. It minimizes stress of the last minute, because now we know that things are working up front. It also is easier to move tasks. What do you mean by that? Is basically, let's say that Bob in a certain team had 10 functions to implement. 5 of them are already working, but he hasn't pushed his code, and the remaining 5, he's still working on them on his local copy of the repository. But the problem is now everything is together, and it is hard to actually push the code that is working, because his team members might need these functions, but he can't push them because they are still intertwined with the other changes. So he will have to go through a tedious process of, like, okay, what is working and what is not, and will have to basically create, like, what we call a different branch and try to push that branch, etc. So you don't want to go through all that chaos. If you push the code up front, and whenever something is working, it will probably be easier to move that code to your teammates. Okay. But again, do not break the build. Always try to push the code that is already working, or if it's not necessarily working, that at least doesn't break the build, or doesn't break any tests that were already working. Because that will definitely hold the development of your team members, and it can, it will add a lot of stress. Again, if you want to show your team members some of the code that is not working, just try to comment it out, push it, and then they can uncomment it. This way you don't break the build. Okay, so we talked about partitioning up the work in terms of functionality. Sometimes there are other ways to actually split up the work. You can split development and testing. So one person basically is responsible for developing new features, and the other person is basically responsible for testing and debugging all of these features. And the good thing about this is that testing and debugging is massively parallel. It's probably the only thing in software development where if you add more people to it, you will definitely get faster in it, because debugging doesn't need that much communication. You just need to basically dig into the code and try to root cause where the issues are. Okay. And the last thing is what we call pair programming. Has anyone heard of the term pair programming? No? Okay. So the name is pretty intuitive. Basically, it's one computer and 2 developers working on it. Why do we do that? Basically, someone would be called the driver, who is the person writing the code, and they focus on the details of the features that they are developing. Another person is called the navigator, who is only basically sitting next to the driver and reading the code as on the fly, and trying to point out mistakes if there are any. And he will focus on the basically corner cases that the driver might have forgot about. Basically, and he will keep giving feedback to the driver as they code. And the driver at some point will get tired, so basically they switch their roles frequently. And we also do that because we need each of you to be committing new code to the repository. So we will see who committed what. So don't work from one account only if you are doing pair programming. Just make sure that you are switching frequently and switching even the login info. Okay? The good thing about pair programming is that it helps the 2 developers to talk a lot and discuss ideas, discuss any corner cases that the developer might have forgotten about. There is a good tutorial. I know it's pretty intuitive, but there is a good tutorial if you are interested about this online. I had the link here. Okay, but is pair programming a good idea? Do you think that it wastes more time to actually put two people on the same computer or not? Any ideas on this? Yes, go ahead. Just a second. Yeah.
I would say that you have to use it like somewhat sparingly.
If you use it, sorry, with what? Can you?
You have to use it sparingly, like only for the more important functions, or the functions that, that other functions rely on, for example.
Yeah, okay, so basically if there are more important functions or common functions that will be used by different parts of the project, maybe pair programming is good to make sure that there are no mistakes, or like we catch all of the corner cases in that specific function early on. That's a good idea, but there are actually studies on this, and it showed that it can work, especially for new teams or for non-expert developers. So these studies showed that basically, even though that you are probably writing less code, that code has higher quality. It has less mistakes. So look at this figure, for example, and think of this circle to be all of the mistakes that the driver can make if he works on his own. And these are the mistakes that the navigator would do on his own. But if they are working together and discussing things on the fly, the probability of doing mistakes is going to be less, and the number of mistakes at the end that will pop up is probably less. So it's less code, but higher quality and easier to debug. Okay? It also helps the team to be cohesive, because now you are forcing a lot of communication between each other and throwing ideas here and there, which also, and this builds trust and understanding of each other. It also grows the expertise of the team members. So let's say there is one person in the team who's a strong developer. He's been doing coding for a long time, and another team member is like still a bit beginner. It will actually help share knowledge across the team members and make each other strong, better coders. Okay. So yeah, as I said, most of the studies showed that pair programming will make the teams more productive, especially for the new teams or for the non-expert developers, because now it helps them learn new things. In Cerebras, for example, whenever someone comes on the team, it's to get them up to speed. We basically pair them up with a senior developer in order to for them to learn how we do things at Cerebras, for example. Okay, so you work in a team. There will definitely be some conflicts. We talked a little bit about how to avoid those conflicts, but conflicts will arise here and there, and it's more bound to happen. So let's talk about how to resolve them, whether on a technical or non-technical level. Okay, so earlier on I told you about not to break the build. I kept repeating myself not to break the build and try to push things that don't basically break your code from compiling. But sometimes this is gonna happen. Okay, so if that happens, how are we going to solve it? So let's say Professor Chong and I are working on this project, and I come do a git pull and try to build. I found that that the code is not compiling, and the build is broken. So I send him this email: Alan, this build is broken. Can you take a look? I'm gonna give you a minute to basically think about this email. Tell me about the strengths and weaknesses of such an email. Is this a good email? Am I missing anything? Or is this good enough for Alan to go and do his work? Okay, so I think most of you were agreeing on the fact that this email is pretty vague. Like, it doesn't necessarily list what the problem is. It doesn't even say it doesn't even prove that it's Alan's fault, for example. How do we know that this is he broke the build? It doesn't have enough information to for Alan to go and work on. So yeah, the first line is basically not very specific, and it's not clear that it's his problem. And there is also no sense of urgency. So like, even though the build is broken, is this a really important thing? Do we need it? When do we need it by? When do we need it fixed by? So there is no urgency in the, if there is a required action or not in this. Okay, so let's go to attempt 2. I modify the email and I say, Alan, once again, you broke the build. Sarah and I can't work. Sarah is another team member. This is unacceptable, fix it. So who wants to buzz in and tell me whether this is a better or a worse email than the previous one? Yes, BE05, just a second. Go ahead.
I'd say it's a lot worse because it's very...
Sorry, can you speak louder in the mic?
Sorry. I'd say it's a lot worse. It's really aggressive. So if anything, it's just going to sort of break the team dynamic apart. It also doesn't say where the problem is. So it could be like a logic error, a compile time error. So like overall, like, it's not useful at all.
Yeah, okay, so these are 2 good points. One, it's still a bit vague. We don't know what the problem is. And second, it's very aggressive. The tone of the email is basically telling Alan to go fix it, and in a very aggressive way. And this will affect the team dynamics. It will affect how the team members communicate with each other, and it will probably stick with Alan for a long time that Abid sent me this really bad email, and I probably hate him. Like, I don't want to work with him anymore. And going on, it will definitely affect the team dynamics. So these are good points. So yeah, even though there is a little bit of urgency in this email, like fix it, but it still doesn't specify when do we need it fixed by, why is it that important. It's very vague. There is still no evidence that it's even his problem. And as you guys said, the tone is angry and condescending, and this will definitely affect the team dynamics. Okay, so attempt 3. Now it's a very long, detailed email. We are saying that there are many compilation errors in street.cpp. The last commit to this file was at 8 p.m. last night by you, so we think it's your code. This is holding Sarah and me up, and we can't compile. Please take a look ASAP and let us know when you can fix this. If this can be fixed by the next hour, we will have to revert your code. Is this a better email or not? Any suggestions? Anyone wants to weigh in? D06, did you buzz? Yeah, just a second. Go ahead.
This one is a lot better.
A little bit higher, please.
This one is more detailed.
Okay.
It's more specific.
Okay, yeah. So this has more details. It's definitely less vague. We know what the problem is. We know that there is at least some proof that it's Alan's problem, that he broke the build last night at 8 p.m. And it's less aggressive. We are just stating facts in the email that, okay, it's probably your issue, please go ahead and fix it. And it does have some urgency to it and some required action, because it tells, and the email says that if you don't fix it within the next hour, we will have to revert because it's holding us up and we cannot continue working on it. Okay, so there is a specific problem, and it conveys urgency. The tone is respectful, it's not aggressive as the previous one. There is a tiny bit problem here in this email, is that the broken build is kind of buried in the text here at the bottom. Sometimes we get a lot of emails, and it's probably hard for us to read each one in detail. So maybe in the header message of the email or so, say that the build is broken. But that's definitely a better email than and better communication than the previous ones we saw. Okay, so that was an example of a technical conflict that can happen in any software development project. Now let's discuss ways to solve non-technical conflicts. Let's say that you have a teammate that is not meeting his commitments, and we want to come up with ideas onto like how to resolve this on a team level. Okay, I'm going to give you a couple of minutes to discuss this with your teammates. Now, this is a very important skill to have. It will definitely happen to you in the industry if after you graduate. And some companies actually always ask this question in an interview, like if you how do you resolve conflicts within team members? So I want you to think about it thoroughly and like take it serious and try to come up with ideas to solve it. Okay. So, anyone wants to weigh in on this? Like, let's say Professor Chung and I are collaborating actually on this course, and I'm not meeting my commitments. I'm very late on my releasing assignments, so he reports me to the chair. Is that a good way to handle things, or do you think we can do something about it? Anyone wants to weigh in? E05 again. Yes. Whoops, sorry. Go ahead. And speak closer to the mic, please.
Okay, I'd say maybe to start, just ask them how they're doing to see what their situation is. So rather than going in with like an aggressive mindset, like, oh, you're not doing your work, just ask them if anything's going on in their life that's preventing them from meeting the milestones, and just follow up with what you can do to support them. That way, at least there's a good bond between you and your teammates, and then try to figure out a plan to get things done as well. And
Sorry, I couldn't hear the last part. Yeah.
Forgot what I said.
Yeah, go ahead.
But just to sort of emphasize the urgency of the task itself, and try to see ways you can support them as well.
Okay, yeah, so basically it's definitely not a good approach to go and report them from the beginning. You need to talk to them first, make sure that they understand that there is an issue here, and try to work on it. Sometimes it takes time. Sometimes you have to talk to them multiple times. That's okay, you have to be patient. And just emphasize that we are going to be late. We need to fix this issue sooner. Okay, yeah. So that's a good suggestion. So again, talk about it. Always talk with your team members, whether privately or on at the level of the whole team. As long as they understand that there is an issue, at least you've done the effort, in order to, and show that you are trying to fix some of those issues. Okay? It's better be in person, not over Zoom, because, or through email, because we saw some of the examples in the emails that, like I showed earlier, is that the tone can be really aggressive in the email, and it will make the other person a bit more defensive. Be factual. We just need to state facts. We state that, okay, these 3 items are a bit behind the deadline and we need to meet them. Are we going to meet them? Don't be emotional, because once you become emotional in a professional environment, the other person will be more defensive, and it will lead to a lot of conflicts in the team dynamics moving forward, and probably the team will disband. Okay? And as I said, you're likely to have to talk multiple times to your team members, because maybe they are going through something outside of work and like it's not allowing them to meet their deadlines, but that's fine. You have to be patient and understand what is going on. Okay? One other thing is that try to write the outcome of the discussions that you had on the wiki. Don't just say verbally, okay, I'm gonna meet, we're gonna change the deadline to next week. And if you don't track it, it will probably happen again and again. So if you track things on the wiki and saying that, okay, we were initially setting this deadline to this task, but due to unforeseen circumstances, now we have to push the deadline. If everything is documented, you, your team members, the TA, and the CI all know that what is going on in the team, and we know about the team situation. Okay? And if all of these don't work and your team member is still basically behind their deadlines, it's fine to talk to the TA and CI. At the end of the day, they are kind of your mentors or managers, and they will help you to try and resolve some of these issues. But as long as you showed that you've done the effort to try to resolve them, these issues among yourselves, that will show that you guys have a good management or project management level. Okay. So if you go behind their back and talk to the CI or the TA immediately, this will definitely break their trust. It will definitely affect how things will go moving forward, and maybe they get defensive and they don't want to do the task anymore, and it will create more issues that you really don't want to go through. Okay, so that's it about resolving conflicts. Now let's get a bit more technical and go back to our software development project. We're going to talk about testing. So the philosophy you should have in any engineering design is that if you didn't test it, it doesn't work. Has anyone heard of Murphy's Law? Yeah, okay. So Murphy's Law says that if something can go wrong, will go wrong. So this is basically a saying from the 1940s, I think, about rocket design. And it was actually the design failed and things exploded. So basically, this is saying that if something disastrous can happen, probably will happen at some point. And in software, you don't want that. You want to make sure that you catch those disasters early on before releasing your product to the customer. So that's why we always have this philosophy of we need to test everything and prove that it is working. Okay. You should have the mindset that you should have the mindset to look at what the program is doing and not what it's supposed to do. We know that in the M1 handout that we gave you that this function is supposed to do the following. For example, this function will return the length of the street. But if it's not showing us in examples or in testing, that means that it's broken, right? So we should always have the mindset that we need to look at what the function is doing and not what it's supposed to do. Once we can prove that it is doing what it's supposed to do, then we can move on from this. Sometimes you miss some of the corner cases, and we know that it's supposed to cover these corner cases, but your code doesn't implement these, and it will miss them. So we know that it's supposed to do this, but it's not doing it, right? Okay, so when do we test? Some people develop tests at the end of the project, but that's probably not a good idea because debugging those issues at the end, like if you found that things are not working as expected, is going to be more difficult. If we build more tests and debug along the way while we are coding, this is basically called test-driven development. It will help us catch off most of these issues early on and will minimize the risk of handling a lot of errors at closer to the deadline. And this fits in with the agile development. Remember that in agile development we have some initial plan about things. We try to build a prototype, and then we see how things are going and try to reiterate. So if we have a test-driven development while we are building that prototype, probably we will have less mistakes and we'll have to reiterate less, but definitely there will be some more issues and you will have to. So we always do a test and evaluation cycle in every product that we have. Okay. The good thing about this is that they are also the detailed specification of each function. So we know that we gave you, for example, the header file in M1, and we told you that what each function is supposed to do. Now, okay, we have that, but the function or the implementation doesn't know that, right? So if you build the tests along the way, along with your implementation, now you are giving you are translating that English spec from the handout to a programmatical spec so that the function knows that it's supposed to do this. And you are testing it on the fly so that if there are any issues, you are catching it, and if there are any corner cases that are missing, you are catching those while you are testing them. Okay, so there are 2 or 3 kinds of testing. Usually, like at the least level, there are 2 kinds of testing. Something called the end-to-end testing and what we call the unit test. The end-to-end testing are like which are like any test that you've probably been doing so far, where basically you have some user input and you have some expected user output, and you are basically checking the whole program, running the whole program to see if you give this input to the program, is it going to give me the output that I'm expecting. The other type of test is unit testing, and these tests are basically smaller tests, and they are more targeted towards small pieces of your code, not necessarily the whole product. And basically you are just making sure that each function is working on its own as expected. So once you basically put everything together, you know that each function, you are sure that each function is working fine. Now let's test it then we do the end-to-end testing and make sure that everything is working together. Okay, so anyone wants to weigh in here? Basically, what are some of the strengths and weaknesses of unit testing and end-to-end testing? What are the differences? Like, are they both important? Is like, or do we only need end-to-end testing? A07, go ahead.
You should do both because system tests give you a more overview of your code to see if it all integrates together effectively. But the downside is that it doesn't have very specific cases all the time. While unit tests give you that specificity, but you don't know if it's all going to integrate together.
Right. So sometimes some of these corner cases that we talk about, they might be captured with the unit test. We might not hit them though in the end-to-end test. Sometimes like the users enter random inputs and we don't ever had these issues. But that doesn't mean the code is working. The code is still broken, but we haven't coded. That's why unit tests are important. On the other hand, end-to-end testing is still important because we need to make sure that before releasing the product to the customer, that the whole thing is working together and it's working as expected. So basically, end-to-end testing doesn't leave any gaps. It tests the entire system. Some of the problems that in end-to-end testing is that they are harder to debug. Why? Because the code, the issue can be anywhere in the code, and if we haven't tested the different components on their own, it's very hard to figure out where the issue is. In the next tutorial next week, we'll basically teach you how to do effective debugging, and it will show you like how we try to root cause a problem on a bigger scale. Okay. So on the other hand, the unit tests, they are easier to debug, they are less fragile because we know what each function is supposed to do, and we are trying to give the spec to that function and test that it is meeting all of the corner cases that we are trying to cover. Okay? Their only problem is that they don't cover the whole system, and you will probably run into issues if you don't do the end-to-end testing and only unit testing. There is also an extra component, a type of test that is a bit more wider than the unit test and less wider than the end-to-end test. It's called integration testing. So in integration testing, we basically build bigger unit tests. They are kind of still unit tests, but like they are grouping multiple components together, or like multiple classes together. So we build unit tests to test each component alone. Now let's build some tests that test basically 3 or 4 components together before going into the whole integrated system or the whole end-to-end tests. So it adds more difficulty to debug, but it's still easier than the end-to-end test, and it will give us more confidence in that the code is doing what it's supposed to do, even when you are grouping them together. So the idea here is that we usually have in any software project more of the lower level tests. So any feature that we build, for example, at Cerebras, we have to write a unit test along with it so that whenever we push that new feature, we can test it on its own. And then the higher you go in the test level, the less tests you have for these. They still cover a wide range of scenarios happening from user inputs, but they are going to be less because we know what the user will enter, what kind of user input we will have, and we want to make sure that we at least cover those. So that's it for what I have today. And if you have any questions, I'm happy to answer. Thank you.
So I'm working on the get OSM node tag value function, and functionally it works, and it passed the M1 func OSM Toronto Canada test. But when I ran the M1 performance test, I get this error: expected to run tests over 111 milliseconds, but took much longer.
Okay, so we need to optimize the performance.
Right, but when I decided to double check that by copy